afternoon, dear friends, and welcome to our popular IoT webinar when we share our ideas and we talk about technologies and trends, specifically in IoT area. I'm Alan Fabik, founder of HARDWARIO, and this is my friend Pavel.
Hello, everyone.
Founder of HARDWARIO too.
Yes.
And Chief Technical Officer.
Yes, I'm the guy behind the curtains.
Yeah. Today we have a very special topic. We will dive into manufacturing, so-called Industry 4.0.
Industrial IoT, etc.
And the question is, are we brave enough to go into manufacturing, IoT in manufacturing?
Sure we are.
Sure we are, of course.
We have been already doing so for some time, so that's the reason why we are open to sharing this with you and excited to introduce our activities and we hope that you will like it.
Exactly. And of course, as always, we will have plenty of time to answer all your questions in the end of our webinar. So please don't hesitate and ask your questions. Use our chat, and we will answer your questions later. Probably, definitely. So let's start with how it started, how HARDWARIO started journey in Industry 4.0.
So I remember our very first project in this area. It was back in 2018, 17, maybe 17 actually. Yeah. And it was for Toyota, big brand.
In that time, it was Toyota, Peugeot, Citroën Automotive, TPCA. Now it's Toyota, but only. For our French friends, we started with French cars.
Credit goes where it's due. Yeah. And the project came from our customer who has purchased Tower, the IoT kit, by the time Big Clown. And he liked the project a lot and he decided to utilize it at work. And the problem he was solving at that time was monitoring of the temperature of the scissor lift.
Yeah, it was inside. It was the area which is called predictive maintenance. And yes.
Yeah, and basically he purchased our components, and with a little help from us in firmware area, he was able to monitor temperature in fairly fast pace. And he was using Tower components, and he was transmitting data over radio to radio dongle and Raspberry Pi, on which we had installed this popular open source stack, InfluxDB, the time series database, and Grafana for visualization. And we haven't heard about the project for some time, but later Marek came back and he was presenting the project to his management and international colleagues from Japan, and there was apparently a big applause because he was able to solve this problem, which saved millions of Czech crowns with the devices in the range of roughly.
It was 500 euros. Yeah. So let's switch to euros. So he saved hundreds, thousands of euros, and the cost was 500 euros. That's why they applaud so much,
And not only to our colleague Marek, but also to us during our exhibition in London. Just by the way, we met them, we met those people from Japan, and they came to our stand and they said, "Hey, we know you." I said, "Who are you? I'm sorry." And I said, our colleague was presenting your solution to us, and it was this, and then we connected the dots, so it was very nice.
Big surprise during this exhibition. Yes, it started, and we were a little bit shaky because industry, we weren't so so sure that we won't go to this area, because before we focus on makers and schools, but we realized that it can be something important for us in the future. And the second project came right after this, and it was inside the one big printing company called OTK.
And this company prints a lot of labels. You can basically all Czech beers have labels from this printer company.
And German beers, because it's like billions of labels printed.
Yes.
Per year.
And they approached us with a problem. They wanted to monitor the frequency of the machine that cuts these labels, if I'm telling correctly. And by the time, not very experienced with industrial machines at all, but we came to the machine and we observed that there was this LED indication blinking and it synchronized with these cuts. So we took our tower kit again and we used phototransistor, connected to it, and we were gathering data to Grafana and found interesting observation because
yes, it was it was very impressive because they found out that their takt was should be around 18 per minute and average was about 4. So they improved their production in just a few days. Now they have precise data and they can work with them, which is it was like a miracle for them compared to.
If I remember correctly, they even decided not to buy another machine.
Because
which was a huge savings on the investment.
Definitely. So they are like in the first case, they are using a tower, but for communication, there was a switch from
radio to LoRaWAN, and by the time we helped them to establish the network through our Czech local LoRaWAN provider, ČRA, and the project has been running since then happily ever after.
That's great. And for the very first time, we start promoting this approach as a non-invasive IoT in manufacturing and production. But it was just beginning. And some big customer came to us, and this customer was Škoda Auto. Let's talk about this project, Pavel.
Okay, so Škoda Auto approached us with a project for their plasma line. They needed some system for indication that something goes wrong. Typically in automotive industry, there has been very long established standard from Japanese again. Called Andon. It's a system that uses lights, but in our form, we of course digitize everything. So we helped Škoda to build such electronic Andon system consisting of a few buttons and some light indication mounted at the ceiling of the production hall. And again, this system was using tower. Again, it was using LoRaWAN communication because of the benefit of the long-range communication, but we used our own infrastructure. By the time we decided to pick industrial-grade LoRaWAN gateway from company Multitech, this box looked great until the point that Škoda Auto has very restrictive security policies, and we didn't match the requirements with Multitech in one specific point. And we found out that actually this requirement is satisfied by MikroTik. And what happened at the time is that MikroTik was launching the new communication card for their routers, and it was LoRaWAN card. So we ordered the very initial pieces when they appeared in the Czech Republic and started testing it and found out it works really good. So we started basically an era of encouraging our customers to build their own LoRaWAN networks if they don't want their data to leave their company's facilities and so on. And we were basically delivering the solution which consisted of a MikroTik router with pre-installed LoRa card. We selected this industrial-grade embedded Linux computer from company OnLogic, which is they make really nice computers. But in the end, we came to the facility with a set of boxes, and they all had regular AC line plugs. And many of you know that this is not very compatible with the habits people are used in serious industrial automation. So we were looking around and decided, all right, how about if we integrate all these things into one single box? And we created our own products that we are introducing for the very first time. It is called Ember. It comes with an enclosure very similar to our chest tray. You can see his little brother next to it. And this Ember box actually integrates the OEM version of MikroTik with two slots, typically pre-installed with LTE card for independent internet connectivity, and LoRaWAN card. Next to it, we have developed a main board for Ember, which carries all the power management. It can also recharge the lead-acid battery for eventual dropouts in the power supply, but it integrates embedded Linux module. So the whole stack, the whole LoRaWAN infrastructure is running inside this box, which is actually IP67 protected. It is possible to power it from a 24 volts DC power line, which is de facto standard in industrial automation. It has also these waterproof connectors. There are some internal antennas for LTE. Of course, you can also connect it to local infrastructure through Ethernet. There are 3 Ethernet ports. Two of them are actually usable for your network. One of them is utilized for the embedded Linux machine. And there is an optional USB connector for some additional accessories, dongle, radio dongles, and so on. So really flexible box we are introducing in the market and we are very proud of. And this one can be used as a next step in evolution when you are building your own LoRaWAN solutions.
Yeah. And we did so for Skoda, but in the end we know that this is not exactly what we want to do as a HARDWARIO, as a relatively small team of developers. That's why we are building this strong partners network. And even for Skoda Auto, this project has to be sustainable. Sustainability is a magic word because you need to somehow care about this project. You have to develop this project. And you need somebody who is near to this factory, who knows people inside of factory. And so we need partners. And even for Ember, to building IoT hotspot, IoT network, you have to care about this. So maybe this is the reason why we are here today, just 2 of us. We are not here with our partner because we have many of them in this era of manufacturing production.
So we wanted to be fair.
But we want to mention at least few of them, and one of them is they are our partners and friends from IQ Hubs. So let's talk a little bit about what they are doing for Industry 4.0. IQ Hubs, they have, let's call it magic box. They can send you this box with a few components inside.
Yeah, it's the whole set actually. Yeah, which consists of this rotary switch, which can indicate a lot of states. Our Andon presented previously can indicate just a few states using these buttons, but they can indicate like 12 states or something.
Yep, exactly.
And they also have a neat optical sensor, a very good quality industrial sensor for monitoring OEE of the frequency and the tact of the machines. And they are connecting devices through LoRaWAN again. So,
that's perfect concept. How to start, how to boost this digitization, how to start, in your factory. They offer this as a service. So this is a nice example. They are using our devices, their technology, their application, and you can have data within several hours. That's
actually,
great.
Their customers can already start using it themselves.
Yeah,
they are making it easy.
That's great. So in that time, when they approach us, we started thinking how to do it more professionally. I mean, what we are doing in industry. And now it's time to talk a little bit about possibilities how to monitor this OEE, this tact of the machine. What can we use as a technology? So let's talk a little bit about this. And let's start with probably our preferable method, which is to connect our device, just a device, to PLC.
Yeah, if this option exists, it's actually beautiful because then you don't have to deal with any kind of sensors, and you can either connect to existing outputs the PLC is already providing, or you will come to agreement with the programmer of the PLC program, and you will come to modification that is providing state outputs, some event outputs, and our Chester device is counting those inputs or immediately reacting to those events, simply gathering data based on these I/O states and sending them out. So that's one method. The direct method, there is another interface. Many of the PLCs, or basically all of them today, are equipped with RS485 Modbus interface. It's a very old-fashioned interface, but very, very well known, very spread. And we can again implement readout of the internal memory registers and states from Chester to Chester from these PLC machines.
But sometimes we are not allowed to connect through PLC because of people, because of policies.
And we are non-invasive.
Yeah, we are non-invasive. So. And we have to go this way. So let's talk about these sensors. Let's start with capacitive sensors.
Yeah, so typically from a machine there is some production yield, and you want to count pieces, or you want to measure frequency of the products or the machine, or some internal motor and so on. So for this you are using sensors, and there are several types of them, and as you mentioned, capacitive is one of them. Actually, we have a sample of one such capacitive sensor here. You can find
it's inductive, but you can
it looks the same. Thanks. And it comes in many form factors, but many of the mounting options are standardized. There are these M12 holes, and there is the whole range of accessories and mounting brackets you can use on the machines. So this is like golden industrial standard. Many of these sensors are actually equipped with adjustment elements, like potentiometers. There could be indication LEDs, so you can mount it in the production machine, and immediately, without tweaking any software, you can get immediate output and see if the sensor is reliably detecting the throughput and counting the yield of the production. So capacitive is good for detecting, I would say, anything that changes the environment, because this is what capacitive sensors does. Disadvantage is that you cannot use it for very long distances, typically a couple of centimeters, but it can detect even plastic objects. That's a huge benefit of capacitive sensor.
And inductive?
It looks actually the same, but it's very good for detection, and it's more reliable actually for detecting metallic objects. Yes,
that's great. We already mentioned our partners IQ Hubs, and they are using optical sensors, which can be used in.
Yes, optical sensor is great because you can mount it from greater distance. Again, it comes with a lot of variants, and some of them can even detect distance up to meters. For those sensors, however, you typically need to install some reflective backplate, sometimes even polarizing. There are also infrared and visible red or laser beam sensors. So again, pick the best one that fits best to your machine. Sometimes it is even necessary to swap the sensors. You have to try it, but thanks to the unified simple interface, the sensor is on or off. It's fairly easy to swap the sensor in the field and to use different ones. So it all comes down to experience and some knowledge what could be the best shot, but sometimes definitely. You have to go and try.
In some cases, we are using a whole probe, which is good because you need a magnet. But for example, when we have one special project with our partners, company Snadny, and we are monitoring the transport belt, the belt. So in this case, it's very good. You will glue the magnet on this belt, and you can monitor the movement, the speed of this belt, ultrasonic. For some cases, and we have this nice current probe.
Yes. So if you want to monitor some motor and see whether it's running or not, you can use this non-invasive current sensor. They come in two basic types, I would say: AC current sensor, which works on a transformer principle, and the DC current sensor, which is a strange name because DC current transformer doesn't exist, but they call it that way because there is the Hall sensor, and it can detect direct current, which generates the static magnetic field, and the strength of the magnetic field is proportional to the output differential voltage on this sensor.
You can already check our portfolio, which is on our online shop, and most of these sensors are already integrated, so you can use it right away. And right now we are talking about non-invasive method inside one area, which is monitoring of OEE, overall equipment efficiency. But in industry we can cover more areas. OEE is the first one, efficiency. The second is monitoring of environment. So we got plenty of other sensors like typical temperature,
carbon dioxide, volatile organic compounds, dust sensors.
Dust sensors, yes, what we have. Then we can, another area, and we already talk about this, it's notification systems like Andon. Then utility, monitoring of utilities, energy, water, gases. This is what we do. And predictive maintenance, which is fifth area, which is most popular in this IoT in production and manufacturing. Great. I think that now it's time to talk about these sensors, the way how you can customize firmware behavior of these devices. And there is a great news for our partners and customers because we have a new version of Chester.
Yes, precisely. We are coming up with a new generation of our successful product, Chester 3, which has plenty of additional interfaces, and we will actually talk about details about the real features of the product in a special dedicated episode. However, what we are preparing is the SDK, software development kit, for this, and we are opening these APIs and samples applications so our partners and customers can customize behavior of their gateway device and prepare their own applications for it.
Perfect. So we have sensors connected to our IoT Hub Chester, and our partners, they can modify the firmware. And what about data? How we will send, how they gather data from these devices?
So we were speaking about non-invasive installation on the machines, but in the same way we can also emphasize non-invasive communication, because sometimes you don't want to, or you are not even allowed to interfere with local infrastructure. Still you want to accomplish the project in a fast manner. Hereby we are proposing two communication options. Either you will go your own network, your local infrastructure that is independent, and it can be done through this Ember product, communicating to your cloud services through LTE. Or it doesn't communicate to cloud whatsoever. It can stay local. That's the great benefit. Or you want the simple, clean approach with a single unit, and you can communicate directly from Chester narrowband variant to HARDWARIO cloud and fetch data through REST API or callbacks. So these are two methods we are proposing for non-invasive industrial IoT.
In fact, I strongly believe that factories, I mean management and people, they don't care about these communication channels. They don't care. They want to see data. They want to improve their production. So it's on us what we will offer. What is the best solution for them? In some cases, it can be LoRa. In some cases, it's much better option to go with narrowband IoT. Both of them, they are secure. They are safe with all necessary security
mechanisms and there is this
yeah.
various layer separation which helps in that regard.
This is very important, that we are not, we don't want to go to internal network because they want to somehow threaten data inside of factory. So this is what we are doing with how we are transferring data. And now it's time to tell you a little bit more about our referral project, which is running in ArcelorMittal Tubular Products factory. What we achieve with a little, what they achieve with a little, and what results we can see even this project is running several weeks.
And we are referring to this cutting machine. We were able to monitor and improve the efficiency. So how we did it?
It started again very simply. It was a very simple request. Hey, we need to monitor the takt of this machine, this cutting machine. We want to be sure that the efficiency is on the level we want to have this efficiency, and we want to see if we can improve our performance. For the very first time, there was somebody who helped us a little bit, because this guy who is a programmer of PLC helped us.
We just brainstormed and came to the conclusion that it will be easiest for both parties to actually modify the program, and they have prepared auxiliary outputs that are connected wired to our Chester unit, and these outputs were actually the OK and not OK outputs, counting the samples, the takt of the machine, and the state of the machine, whether the machine is on or off.
That's simple.
And we were transferring these data through narrowband IoT and integrating them through Microsoft technologies and channels, and you can talk about
because Microsoft it's a perfect partner. They are helping us a lot, and we are using their technologies. That's again, it's a beauty of this, because if you are familiar with, and of course, who's not familiar with Excel, you will get Excel report. But in this case, we are using our REST API, and we are pushing our data to their Power BI, and they got this sharing mechanism inside of this factory. And the results, guys, it was a miracle. Really, it was a miracle, because in several weeks they improved their production almost like a 25%, as I remember well. It's a little bit volatile, but you know, it was huge, just because they are monitoring this takt of this one specific machine. So of course,
not only monitoring, they had easy insight for the data. That's important, because sometimes you have lots of data feeds, but those data are not analyzed because they are hardly accessible. So what we made in this project is to make them easily accessible through QR code and these daily reports in email.
So implementation was very fast. It means it was affordable, and they got data. Now they are developing this project, and we are happy to share it with you. So don't hesitate. If you got almost the same problem, don't hesitate to ask us or our partners, and we will do it. In several hours, you can have data in your mobile, tablets, in your databases. That's great. That's why we are preparing a special program, which is called factory.report, and soon we will show you how you can use it, how you can register for this program, and how we can help you to monitor your production, your OEE. It's all happening because of our partners. This is something we cannot do as a HARDWARIO. We are a relatively small team of developers, and our success depends on successes of our partners. If you want to become our partner, don't hesitate. Go to our website, register, and we will show you how you can use our technology, our products, how you can monitor production in your region. Pavel, I think that we
We have covered pretty much everything, but we are very much looking forward to receiving your questions. We will be happy to answer them in our Q&A session, so don't be afraid.
Maybe these questions can be about these interfaces because sometimes we talk about these sensors.
Yeah.
But if you can mention these interfaces to make it more clear for
that's actually one area we didn't touch yet, and maybe just to wrap up, because we already said that there are interchangeable sensors like these capacitive, inductive, optical. So what kind of interfaces can we actually connect to Chester? So these general outputs, they are simple. It's either dry contact or this active output or this NPN output, just shortening the signal to ground. So that's like the golden standard for these simple sensors. We can also measure voltages, proportional voltages between 0 and 10 volts. Pretty much the same for current loop sensors. Very well settled standard 4 to 20 milliamps current loops. Also, we can interface digital type sensors providing Modbus communication interface. Yes, and there are probably more coming in the future. There are also other industrial standards like HARD or IO-Link. Not all of them we are supporting, but on the other hand, for these simple applications, we can happily live for this non-invasive monitoring with these simple interfaces.
Because we are sharing best practices with our partners about how to do it, how to choose the right project. We are using this impact effort method. So you don't have to go with the highest impact project. Just choose something which is with less effort. Simple. Use Kaizen, step by step, brick by brick, and just put a little bit spicy things in your project with Kane method. For example, you can simply allow all workers in your factory by placing QR code with direct access to data, to your graphs, very simply by scanning these codes. So do it with us. Now it's time for your questions, our answers. So let's go to Q&A session. So let's start again. Welcome to Q&A session when we answer your questions. So don't hesitate and ask your questions in our chat. Let's start with the first question, which is regular, about where we store our data, where you can find information from sensors in production.
Yeah, sure. So once you gather the data to this Chester unit, you have these two options we have discussed. When you choose the NB IoT way, you pass the data to HARDWARIO cloud, where we operate NoSQL database, MongoDB particularly. And in this database, we guarantee 1 year data retention. Today, no limit whatsoever, but in the future, we guarantee 1 year. You can always export your data. If you go to device messages, you can click export button, and you can get CSV file. You can specify the starting range and ending date, and you will get all message dump. So probably you will want to store the data outside in your own database. So for that, you can initiate any kind of cloud storage. Particularly with Microsoft, we recommend SQL Server database or Azure table storage. There is also blob storage and data like there are so many options. However, if you choose the second route and you want to work with the data through Ember, you can actually install InfluxDB, which is time series database very often used in IoT systems, locally on Ember. And you can keep all the data in there. Yeah. Of course, you may sync them to your server, local servers, or to your own cloud computers. On the other hand, many of the customers don't want to go cloud if they do this industrial IoT. So thanks to Ember and its embedded Linux computing, you have the whole range of options Maybe one thing we haven't mentioned in the previous part is that Ember operates a Linux operating system, and you have access to thousands or tens of thousands Debian packages. So you can run applications like Node-RED, Grafana, this InfluxDB, PostgreSQL. You can run on your own Python, Node.js applications. Simply anything you can do in this Linux world. So that's the data, how you can handle them.
Yeah. In each case, your data are safe. And this is
absolutely.
This is the most important. I'm still waiting for your questions, but there are many partners ask me what I think about competition in this era, specifically in this IoT in manufacturing. And my typical answer is, don't worry about competitors and competition. There are some really great applications and systems on the market, but there is like a zillion of factories with bambillions of machines which are not connected to the internet, which are not digitized. So we strongly focus on our case, what we are doing, how to simplify the whole process, how to make it more affordable for our partners and customers. And if you will dive into each factory, you will find tens, maybe hundreds of use cases or machines you can connect. So this is our answer. And because we are just hardware guys and connectivity guys, we offer hardware with API. We can cooperate almost with anybody. So if you have some application, we can help you. If you don't have, we can help you too. We can integrate our system with Microsoft, with Amazon Web Services, with other applications like Ubidots. So there is a question from Louis about the Chester revision 3, the new one, and Ember will be multiband in order to be used in different countries.
Yes, so thanks for this question. We have chosen quite a new technology from Nordic Semiconductor, this NRF91, sorry. And this modem comes with global band support for every region, both in NB-IoT and LTE Cat M1, which was not possible with the previous generation of Chester. And yes, there is constant support and updates coming from Nordic. They are heavily investing into this field. And what we have cross-checked in terms of LTE bands, we have support absolutely everywhere. So this is like a future-proof solution we are about to build on our new products.
Great. So hopefully you are satisfied with the answer. What about prices or cost of our solution? And this is a tricky question because, again, we are hardware guys with this API, and usually we supply our devices to our partners as a service. So it means it's a hardware as a service, and it starts like a 10 euros or $12 per month per device. So it's really cheap comparing to other devices on the market, especially in this manufacturing area. But it's just a part of this whole story, of this whole solution. So typically our partners are adding their value, their application, know-how, support, care, all these things as a package. And then they offer their solution. Sometimes it can be like hundreds of euros per device, per machine, but it's really worthy because it saves money from the very beginning. From the very first minute you install this device, you can save money. So it's just a win-win situation for all parties. So this is probably everything we want to say about HARDWARIO devices and approach to industry manufacturing production, what we can offer. As I mentioned before, we are preparing a special program called Factory Reporting, Factory.report, and we will be able to offer free of charge test of our solution, so you can test overall equipment efficiency in your factory. So just subscribe to our social networks and YouTube channel, and you will be informed as soon as we launch this service. Pavel, thank you. Thank you guys for joining us.
Thanks.
And next time, it means next month, we will have a webinar with our partner Adastra, and we will talk about IoT in retail. And we will talk about very successful project with one global brand. So stay tuned. Thank you. Take care. Bye-bye.
Thank you for watching. Goodbye.